Okay, so the cyclone season and the hurricane season in the Indian Ocean, we have North Indian Ocean because of the monsoon. We have a pre-monsoon cyclone season and a post-monsoon cyclone season. The hurricane season in the North Atlantic is typically from June 1st to November 30th, but because of climate change, we're always discussing how the number of cyclones, intensities, intensification rates, and so on are increasing or changing. But the El Nino relation with hurricanes and cyclones to some extent are pretty robust. El Nino tends to suppress the number of hurricanes, and La Nina goes the other way because of various factors that contribute to cyclogenesis, sea surface temperatures, vertical shears in the atmospheric winds, you have moisture loading, heat content, etc., etc. And here there is a nice study that shows why. Well, they use models to infer why the hurricane season of 2023 was above normal despite a very strong El Nino that occurred during 2023. We have discussed 2023 a lot because the warming that happened, record warming in fact, lots of debate about whether we crossed 1.5 degrees C warming threshold and so on. It was much warmer than what we expect because of global warming and the addition of El Nino releasing heat from the ocean and so on. But in addition, many other weird things happened. One of the things is, of course, that the hurricane season was actually above normal despite a strong El Nino. So let's see what the paper is all about. It appeared just recently in the bulletin of the American Meteorological Society, BAMS as it's known. I will be very brief, not read much of the text. We'll look at a few figures and we'll read the discussion and conclusion to get the main points. Okay, the 2023 Atlantic hurricane season, an above normal season despite strong El Nino conditions. Significance of the study: the 2023 Atlantic hurricane season produced above normal activity despite strong El Nino conditions. Cyclone season was also above normal, but the typhoon season was below normal, but it's been below normal for 3 years before that. So 2023 was the fourth consecutive below average year for typhoons in the Pacific. The season had 20 named storms along with 7 hurricanes and 3 major hurricanes. Normally El Nino decreases Atlantic hurricane activity due to increases in the vertical wind shear that I mentioned. In 2023, vertical wind shear was below average, which favors hurricanes because strong shears tend to take away the energy from a growing cyclone or a hurricane. So this was likely driven by the record warm tropical Atlantic and Caribbean sea surface temperatures, which led to tropical circulation patterns that were considerably different from the atmospheric flow typically observed during El Nino events. So we have discussed this elsewhere also as to how the El Nino pattern is superposing on global warming and creating some unusual patterns in the tropical Pacific as well. This manuscript also uses a state-of-the-art climate model to investigate the impacts of Atlantic and Pacific SST configurations on the Atlantic vertical wind shear patterns, which means the wind shear is considered the main cause as to why the hurricane season ended up being above normal despite the strong El Nino. The formal abstracts for scientific audience reads this way. The 2023 Atlantic hurricane season was above normal, producing 20 named storms, 7 hurricanes, 3 major hurricanes, and seasonally accumulated cyclone energy, seasonal accumulated cyclone energy ACE, as it's called, exceeded the 1991 to 2020 average. So there was there were favorable conditions. Hurricane Idalia, I don't know if it's pronounced Idalia or Idalia. Idalia seems like a Spanish name, was the most damaging hurricane of the year, making landfall as a Category 3 hurricane in Florida, resulting in 8 direct fatalities and $3.6 billion in damage. Above normal 2023 hurricane season occurred during a strong El Nino event. El Nino events tend to be associated with increased vertical wind shear across the Caribbean and tropical Atlantic, yet vertical wind shear during peak hurricane season months of August to October was below normal in 2023. The primary driver of the above normal season was likely record warm tropical Atlantic sea surface temperatures, which are presumably related to anthropogenic forcing or greenhouse gas increases, which effectively counteracted some of the canonical impacts of El Nino, so interaction of natural variability with global warming effects. The extremely warm tropical Atlantic and Caribbean were associated with weaker than normal trade winds, driven by an anomalously weak subtropical ridge, which is a high pressure center that sits over the subtropical oceans, resulting in a positive wind evaporation SST feedback. So if winds are above normal, then evaporation increases, SST cools, and the other way, if winds are weak, evaporation is reduced, SST is warm, then you can have further feedback to the winds and so on. We tested atmospheric circulation sensitivity to SSTs in both the tropical and subtropical Pacific and the Atlantic, that the extremely warm Atlantic was the primary driver. Sorry, I jumped there. Using the atmospheric component of the Community Earth System model version 2.3, we found that the extremely warm Atlantic was the primary driver of the reduced vertical shear relative to other moderate and strong El Nino events. The concentrated warmth in the eastern tropical Pacific in August to October may have contributed to increased levels of vertical wind shear than if warming had been more evenly spread across the eastern and central tropical Pacific. So El Nino patterns themselves have various flavors, more warming towards the dateline, more warming in the east, or spread out, and so on and so forth. So we'll look at the pattern in a minute. Tropical TC activity compared with the long-term average 1991 to 2020. 2023 had 20 named storms out of, as opposed to 14.4, that's the average. So it was 139% higher. Named storm days were over 100, whereas average is 69 or so. The Hurricanes 7, similar to the average. Hurricane days 31.5 versus 27. Major hurricanes 3 versus 3.2, so similar. Hurricane days 7.25 versus 7.4. ACE was 148 versus 123, which was 120% of the long-term average. So named storms were above normal. So this is the 2023 August, September, October averaged SST anomalies relative to the 1991-2020. Remember that El Nino peaks in December, January, February, but strong El Ninos tend to peak, tend to appear as a pattern as early as the summer of the same year, which happened in 2023. In fact, was predicted very well, very early on, and there is this cold, warm temperature, but you can see that this here is different, and this is argued in a paper that this is related to combination of El Nino and global warming, and this is also not canonical. So we will see what are the impacts of this warming here versus this warming, which is much more focused here. El Ninos tend to be, somewhat like this. They're called canonical El Ninos or cold tank El Ninos, and so on and so forth. So they do several experiments, as we'll see here. They are taking all the SST anomalies as we saw in 2023 August, September, October, and only Atlantic anomalies. So they suppressed the anomalies over here, as you can obviously see. This allows the model to respond only to this versus all of this, and then SST El Nino pack, which in their definition is 2023 SSTs with the Pacific SSTs swapped for a 1982, 87, 97, 2002 and 2015 El Nino year composite, which obviously has a different pattern here compared to here, especially this one as well. And this looks, they only replaced these. So you can see that this is more spread out, not as concentrated in the east as usual, as was done in the previous El Ninos and so on. And this is where Atlantic anomalies are suppressed and other anomalies are allowed to go on. So this tells you the impact of this versus this versus this and so on. That's the main idea, but you can see the impact already. Tracks of 2023 Atlantic named storms during June, July, August, September, October, November, and tracks of the contiguous north contiguous US landfalling storms named here. So I won't go into those details, but you can see June, July, August, September, October, November, and this is the landfalling storms. Okay. I jumped ahead a little bit. Yeah, we'll come back. Monthly and daily ACE, accumulated cyclone energy during the 2023 Atlantic hurricane season compared with the 1991-2020 average. Daily ACE was smooth with 7 days, so some statistical massaging there. Accumulated cyclone energy in not squared, it's basically wind squared measure that tells you how much cyclone activity had happened. 2023 June, July, so June was higher, July similar to average, so this is the average ACE. August jumped up and September also was higher, and then it fell down but still higher in October, and November was below the long-term average. And again you can see here accumulated cyclone energy seen without any smoothing, it is smooth. This is monthly and daily ACE during 2023 Atlantic hurricane season compared with the average. Daily ACE was smoothed with the 7-day average, so this is the kind of a weekly average. So you can see that it jumped up as we saw here, and then it went down, jumped up again, and had some peaks, and then dropped off, and then had a later peak as well, compared to the much smoother curve of the average over 1991 to 2020. So what were the reasons? They used these model experiments to show the various patterns that mattered. So July minus March 2023 SST anomalies in the North Atlantic. Here B is July minus March 2023 PI anomalies, and you can see this is March minus July 2023 average 10-meter wind speed anomalies, and this is the average mean sea level pressure anomaly here. Okay. Do I need to do anything here? Let me clarify something. Give me 1 second. I always forget something while preparing, but oops. I'm doing some search in near real time as I'm recording this, but that should not happen. Let me pause and come back. Okay, sorry about that. Okay, sorry about that. Let's see, let's continue here anyways. So you basically want to look at the SST anomalies because they are very important for the growth rate. So you are looking at July minus March to see how things warmed up, and this El Nino warmed up quite rapidly, like the previous strong El Ninos like 82, 83, 97, 98, 2015, 16 as well. In general, the El Ninos don't come so close to each other when they are big. 82, 83, 97, 98, 15, 16, and then 23, 24 came quick, quite early compared to previous separation between big El Ninos. So you want to understand wind speeds, sea surface temperatures, potential intensities, how likely, warm SSTs, potential intensities. So that's difference in meter per second, going from March to July. So obviously things got quite favorable, and sea level anomaly, the subtropical blocking was also affecting the circulation. You had weaker trade winds, weaker vertical shear, favorable conditions for El Ninos despite the favorable conditions for hurricanes, cyclone formation despite the strong El Nino, which typically increases the vertical shear, tends to suppress hurricane activities. So oceanic Nino index and Pacific decadal oscillation, so various August, September, October values during 1979 to 2023 for oceanic Nino index and PDO. They are correlated, of course. People even argue that PDO is just a lower frequency rectification of El Nino, but let's not go there. Oceanic Nino index versus the Indian Ocean dipole mode, also correlation, but you can see where 2023 was compared to the long-term correlation. It was way up here. Nino index was here, and Pacific decadal oscillation was negative, so completely away from the relation that we have seen. Basically because of the unusual warming pattern that we are seeing here compared to long-term average composite of El Ninos. That is the PDO, one part of the PDO as well. And here it's somewhat similar in terms of the ONI and DMI, or El Nino and dipole index. But when you look at El Nino index and the Atlantic meridional index, it's again somewhat out of the ordinary, and the Atlantic meridional mode index is basically something that is computed here, and that is unusual in terms of its relation to El Nino that you see on the longer term average as well. Here is the vertical wind shear standardized, so you can see 2023 was again very unusual. Usually you would expect positive ONI to decrease the vertical shear and La Nina to increase, but this one jumped off over here. And Oceanic Nino index versus mean sea level pressure, also quite unusual. In general, you want to look at these because you want to have some sense of the internal variability. Even though El Nino correlation with hurricane season is strong through vertical shear, there will be large variability around it. So was it just one of those cases where something random happened and threw off the hurricane season, or were there something more specific that could be understood? So a lot of discussions on the models and model results and various dynamics that I'm skipping and jumping to discussion and conclusions. Despite strong El Nino conditions, the 2023 Atlantic hurricane season produced above average activity, likely due to the record warm MDR. My mover is here. He's late by about 1 hour and 30 minutes, but I have to deal with him. Give me a second. Okay, sorry about that. Let's see. I hope I haven't screwed up this with 2 pauses, but I will check anyway. So the discussion then, despite strong El Nino conditions, the 2023 Atlantic hurricane season produced above average activity, likely due to the record warm main development region that resulted in the vertical wind shear and mid-level relative humidity and vertical motion patterns that were much more favorable for tropical cyclone development than normally occurs during a strong El Nino. Though most seasonal outlooks in 2023 emphasized the higher than normal uncertainty given the combination of the strong El Nino and record warm Atlantic main development region, the consensus of seasonal outlooks issued in early August correctly anticipated an above normal season. So the El Nino forecast was very good, considering it was even made in the early part of the year. Typically we have some trouble with forecasts that are made before March, April, May, or the boreal spring, but this one was very confident, and of course in 2024 it made a confident prediction of a La Nina, which didn't materialize. So we are always having these issues in general, especially because of these interactions of anthropogenic warming and natural modes like El Nino and La Nina. Okay, the observed active 2023 season, along with the modeling results presented here, should reduce that uncertainty the next time that a strong El Nino and extremely warm MDR occur together. North Indian Ocean cyclone season was also above normal, which will likely be related to something like this. And the unusual thing there was that despite the strong El Nino, monsoon was nearly normal, but remember that the pre-monsoon season is an active cyclone season. The post-monsoon season is a cyclone season. During the monsoon, typically the vertical wind shear is very strong, or the ocean heat content is not favorable, maybe. There is some debate about how ocean heat content is affected by winds, vertical shear versus wind stress curls that can actually reduce the heat content, which is necessary for growing the cyclones as well. So there's some complexities there to be dealt with. The atmospheric response to this El Nino was more diffuse over the tropical Pacific than normally occurs in moderate to strong El Nino events, potentially due to the lack of anomalous cooling in the western tropical Pacific, which we have argued before is because of a combination of El Nino growing and background global warming anomalies. While the anomalously cold subtropical North Pacific was also unusual for the moderate to strong El Nino events, our model simulations hinted that these cold anomalies may have played a limited role in modulating the main developing region vertical wind shear. Our results demonstrate how simulation experiments can be used. So, these are kind of surgical experiments where you suppress anomalies here and there and assume that there is a linear combination of things, which is never really true in a coupled climate system, but still you get a good sense of the contributions from different regions to the hurricane season, especially via the vertical wind shear. Okay, the 2023 hurricane season was also unusual in that it featured above normal hurricane activity in both the Atlantic and the eastern North Pacific basins, while the two basins typically have an inverse relationship. So when hurricane season is strong, East Pacific season tends to be weak and vice versa, whereas here they both pumped up. So the 4 years since the 1988, which was La Nina, 86-87 was the El Nino. So since 1988, having above normal seasons in both basins were 1998 an El Nino year, so that had already transitioned to a La Nina. 2011-16 was already transitioning out of the 15-16 El Nino, and 2018, which I think was maybe a neutral year or a slightly cold year. Oh, actually it was a La Nina because we had 3 years of La Nina. Although both hurricane seasons ended up above normal, while the Atlantic was undergoing its record-breaking spate of named storm activity from 20th August to 28th September, the eastern North Pacific generated only 3 named storms between those two dates. The average for the long term is 5 named storms in the eastern North Pacific. This study re-emphasized the importance of considering atmospheric and oceanic conditions across the globe when making predictions for the seasonal tropical cyclone activity. Bill Gray, Dr. William Gray, the founder of the Atlantic Seasonal Hurricane Forecast at Colorado State, used to say the global atmosphere ocean circulation functions as a single unit, so it's very much a coupled process. The atmospheric response during the 2023 hurricane season to the strong SST forcing in the Atlantic, Pacific and Indian Oceans highlights the accuracy of this statement about the strong coupling between the ocean and the atmosphere. Anyway, I wanted to read it because in many ways the teleconnections from the El Nino to various regions like western US are changing. Cyclone season responses are also changing, but is this a one-off event during 2023, or are such years going to repeat again? If so, can we be better prepared next time by looking at SST anomalies elsewhere, impacts on the vertical shear in the main development region as well as other regions, like why did typhoon remain below normal, why did North Indian Ocean experience higher than normal season, and so on and so forth. So strong monsoon, still good rain going on, and I'm not using any light, so I look a bit ghostly here, I see that, but it's okay. You are focused on the material anyway and not on me. Okay, see you next time.